Welcome to Algebra 2, 2.3.2. Actually, this is not 2.3.2. It's 2.3.4, I believe. Anyway, operations on rational expressions. In this lesson, we're going to learn how to add, subtract, multiply, divide rational expressions. And this is different. Instead of typing, this time I really encourage you to write. Mainly because these are all full of fractions and they're a pain to type, and well, as you can see, even in our last couple of lessons, you spend half your time correcting your typos. So let's try to get this on paper. Use whatever paper you have available at your house. It doesn't have to be this paper, so if you can't print your paper, that's fine. Just use a regular sheet of paper of any kind. Write on it. Take a photograph of it with your telephone. If you've got a smartphone, that's pretty easy to do, and you can basically drop that picture into this document for your work, so you don't have to write anything or type anything into this document. Let's get started. So today, to add rational expressions, subtract, multiply, and divide, the properties that we use are the exact same properties you use when you add fractions of any kind with just numbers in them. So we're going to practice doing that with these real simple ones, and then we'll do a few more complex ones. This is a very challenging unit for a lot of kids because they never really learned how to do fractions in the first place. So now we're adding variables, which makes it even more fun. But I'll get you started, and then, of course, please ask questions and leave comments on this assignment when you get stuck, and we'll work through it. For 1a, it says add 1 over x plus 1 over y. So I'm going to use a separate sheet of paper to write on, so I don't mess up my copy, but y'all can write right next to the problem if you can print this. Notice the denominators of the two fractions are different, 1 over x plus 1 over y. In order to add fractions, you have to have the same denominator. So what are we going to do? Well, if this is an x and this is a y, what I really need is an xy in each of my denominators. So since the one on the left does not have a y, I'm going to multiply this one by y over y to get xy in this denominator. And the one on the right doesn't have the x, so I'm going to multiply that by x over x to get an xy in the denominator. Now, why is that even allowed? Well, generally, what you're doing is you're multiplying by 1, and multiplying by 1 doesn't really change the value of whatever that is. So if you multiply by y over y, you're getting an equivalent fraction. And if you multiply by x over x, you're getting an equivalent fraction. So that's a legal thing to do when adding and subtracting rational expressions. Next, you'll notice the denominators are the same. So you're going to write xy for your one denominator. And then your numerators are 1y plus 1x. Generally, they'll put those in order and say 1x plus 1y. So I'll just put x plus y. And this is the answer to question number 1. All right, or excuse me, that's 1a, so let's put an a there. The second one is b, and it's very similar. It's 1 over x minus 1 over y. So we've kind of already done most of the work here. 1 over x minus 1 over y. We want the denominator xy, so we'll multiply the one on the left by y over y. We'll multiply the one on the right by x over x. Now the denominators are both xy, and we'll combine our numerators. Now I can't turn these around. I've got 1y minus 1x, so I need to leave it in that order. Y minus x on the top. And the denominator is just xy. So this was b. All right, the third one. Let's see, 1 over x times 1 over y. Now, you would think multiplication, oh, that's way harder. But actually, multiplication is way easier. 1 over x times 1 over y. For multiplication of fractions, you don't need a common denominator. You simply multiply your numerators and multiply your denominators. Of course, if you do see common factors, you would divide those out first. We don't have any this time. There are no numbers on the top, just ones. And no variables either. So there's nothing to divide out. So the answer is simply 1 times 1, which is 1, over x times y, which is xy. So this is your solution to C. All right, the next one is D, and it looks a lot like C. So let's see if we can remember. In middle school, I suppose, when we first did these, maybe you were in elementary, I'm not sure. You guys are advanced, so you probably did it before. Oh, it's divided by 1 over y. So remember how we divide fractions. We multiply by a reciprocal. So in this case, 1 over x would stay. Something about keep, change, flip. You know, I'd never heard that before I came to this school, but apparently that's how y'all are taught by somebody. But you're going to flip the y and the 1. So it would be 1 over x times y over 1. Now, since this is multiplication, again, we don't have any common factors. We simply multiply straight across. So 1 times y is y, and 1 times x is x. And there you have it, y over x. Is your simplified expression. All right, let's go to E. 1 over x squared plus 1 over y. 1 over x squared. And leave a little space when you write these so you have some room to write around. Plus 1 over y. All right, here we're back to adding. So this is like problem A and B. When we add fractions, we need a common denominator, and so here these denominators are not alike, so we'll need to get a common denominator. The one on the left has an x squared, but it doesn't have the y. So let's multiply the one on the left by y over y. The one on the right has the y, but it doesn't have the x squared. So let's multiply the one on the right by x squared over x squared. Now the denominators are the same. They're both x squared y. So we simply write that denominator that they have in common, which is x squared y, and then add the numerators. So I have a 1x squared, and I'm adding a 1y. I'm going to put that in alphabetical order and put my x squared plus 1y is just y. And so this is your answer. Now, I have students that will get this answer, and then they'll continue on trying to divide out. Let me caution you. If you see a plus sign anywhere or a minus sign anywhere, there's no dividing out. You cannot divide out these x's because this is not a product on the top of this fraction. This is a sum. And when you take a squared number and add something to it, it's not something you can divide out anymore. Same here for these y's. I'll have students try to cross those out. Please don't cross those out. In general, don't cross anything out when you see pluses and minuses, because when you do that, almost 100% of the time, I can't really think of a time, you're going to get a wrong answer. So there is no dividing out common factors here. The only dividing out common factors occurs when you have only multiplication, like this one in D or C. Only multiplication, no adding, no subtracting at all. So let's go on to F. And we'll see some of that in some problems in just a minute. I don't know what happened to my poor camera. It just didn't want to focus. There you go. Let's see. On F, we have 1 over x squared plus 1 over y squared. So it's pretty much the same concept. The denominators are not the same. So I'm going to spread these way out. I need both x squared and y squared in each denominator. So the one on the left is missing the y squared, so I will multiply it by y squared over y squared. And the one on the right is missing the x squared, so I'll multiply it by x squared over x squared. Now the denominators match, and I can add my two numerators. So my numerators are x squared and y squared, so we'll say x squared plus y squared in that order. Although the order doesn't matter, ACT is going to put it in that order, so we might as well get in the habit. And then the denominators are the same denominator. You only write that one time. And once again, please, please don't try to divide anything out here. Nothing does divide out. That is simplified as far as it goes. So we'll circle that. All right, the next one is G, and it says 1 over x squared minus 1 over y. So this one looks a lot like E. In fact, it's really similar to E. The only difference is the minus sign. So 1 over x squared minus 1 over y. So the denominators need to be the same. So the one on the left side is missing the y, so we'll multiply this one by y over y, just like we did in E. And the y is missing the x squared. You may notice I'm putting it on the left side. You can really put it on either side, but I try to make them look the same when I write it. It just it makes it easier to see what I'm doing. So just a little pointer there. The denominators match, but here, you remember on E we switched it around and put the x squared plus y. Well, we can't really do that here. We need the y and then the minus the x squared. So we'll leave that numerator in that order so our sign doesn't mess up. So we have y minus x squared over x squared y. And then again, don't divide anything out. Next is h. All right, on h we have 1 over x squared minus 1 over y squared. The denominators are not the same, so we're going to multiply the one on the left by the y squared. So we'll put y squared over y squared. And the one on the right by the x squared. Oops, I did not leave enough space here. Hopefully I can read that. Multiply by x squared over x squared. And so the one on the left and the right now have the same denominator in the fraction, x squared, y squared. So let's combine our numerators since there is a minus sign here. So I do need to subtract in that order, so I'm not going to turn them around. We'll put our y squared first, minus x squared, and we'll leave the denominator x squared, y squared. A rule of thumb is they do alphabetize when possible on ACT, SAT, and other type standardized tests. So you'll notice I put everything in order X, Y when I can, but like on H, I can't really change this. I could write negative x squared plus y squared if I want to be OCD and make sure the x comes first, but in most cases they would not do that. They would write it this way on the ACT. All right, so let's see. The next one is I. It says 1 over x squared times 1 over y. Well, these multiplication problems sure are fun because they're really no work. You'll notice the numerators are both just 1, so you're just going to multiply straight across 1 times 1. And the denominator is x squared times y, so you get x squared y, and that's your answer. So as you can see, multiplication is a lot less involved and a lot simpler. Let's go to J. 1 over x squared times 1 over y squared. Again, I don't need a common denominator. It's just multiplication. So we're going to multiply straight across and get 1 on the top, x squared, y squared on the bottom. And that's our answer. All right, K. We get 1 over x squared divided by 1 over y. Now, division does require a little work because when you divide a fraction, remember you're going to take the reciprocal of whatever you're dividing by, and we're dividing by 1 over y. So we'll write 1 over x squared times the reciprocal y over 1. Now we can multiply straight across. 1 times y is y, and 1 times x squared is x squared. And then finally L, the last one, almost there. We have 1 over x squared divided by 1 over y squared. Once again, you're going to multiply by a reciprocal. So we'll get 1 over x squared, that stays the same, times the reciprocal y squared over 1. There are no common factors to divide out here. We will have that in just a moment, but these are real simple. 1 times y squared is y squared, and 1 times x squared is x squared. So this is your final product, or dividend, or quotient, I should say. Okay, now we've got 4 items. These are way more involved than the ones we just did, but these are all addition and subtraction of rational expressions. And these we will list our restrictions on the variables. That means we cannot use any variable that would produce a 0 in a denominator. So the first actually sum, it's a sum and difference. We have 3y over 4. I would leave some space now because you're going to be multiplying. So leave some space before you put your x over 3. And then plus, I'm just spreading it way out, 5y over 6. So we're leaving a lot of gaps in here. Now, in order to get a common denominator, I need to look at the numbers 4, 3, and 6. What is a number, least common multiple of 4, 3, and 6? Well, it's not 4, 3, or 6, because these numbers don't all these numbers will not go into 6. But if I do 12, I think that'll work. 12 is a multiple of 4, 12 is a multiple of 3, and 12 is a multiple of 6, and it is the least common of those for those three. So if I want a 12, I'm going to multiply this first one by 3 over 3 to get a 12 there in the denominator. If I want a 12 here, I would multiply this one by 4 over 4. And then to get a 12 here, I'm going to multiply the denominator by 2 and the numerator by 2. So 2 over 2. Again, notice we're multiplying both numerator and denominator by the same number, which produces an equivalent expression. So that's why this is a legal thing to do. Next, we're going to multiply the numerators out. So 3 times 3y would be 9y. And we'll put that over 12, because 3 times 4 is 12, minus 4 times x is just 4x. And then 4 times 3 is 12. And then 2 times 5y is 10y. And 2 times 6 is 12. Now all three denominators match. So we'll combine our numerators. You'll notice you have a 9y minus, be careful, this minus goes with the 4x, and then plus 10y. I'm going to put the x first. I like to put x first. So let's put negative 4x first. And then 9 plus 10 is 19y. And then the denominators are all 12s. Now you may think, oh, I could divide the 4 into the 12. No, you cannot divide the 4 into the 12. Plus here means do not start taking out common factors. The only way you would divide out a 4 is if all the numbers in the entire thing are divisible by 4. Like if this was an 18, actually 18 is a bad number, like a 24 or something, you could divide out a 4 here, here, and here. But in this case, you can't divide anything out. So this would be your simplified answer. Okay, let's look at B. We have 2 over 2x minus 4 minus 5. I'll leave some space here. Oh, it won't matter though. I've got to redo this one. 5 over x squared minus 4. Okay, our denominators are different, but in this case, we have something that factors. So this is going to be a big part of what we do with rational expressions. When you see a difference of squares like this, the first thing you want to do is factor this. And this also, this 2x minus 4, has a common factor of 2. So I'm going to factor both of these denominators. So this 2x minus 4 is the same as 2 times x minus 2 if you factor out your 2. And then put your minus sign here, and then let's factor difference of squares. So this will be x plus 2 and x minus 2. Now, once you do your factors like this, you can see if the denominators have factors that are alike. And they do. There's an x minus 2 in both of the denominators for a factor. But what's happening here is this 2 that's on the fraction on the left side is not on the denominator on the right side. So to make this one look like this one, I'm going to multiply this one by 2 over 2 so that they both have a 2. And then you'll notice the one on the right has an x plus 2 in the denominator, but the one on the left doesn't have the x plus 2. So let's multiply the one on the left by x plus 2 over x plus 2. Now the two denominators are the same. So we're going to multiply. The next step is we are going to multiply out these numerators. Don't multiply out these denominators, super important. But do multiply these numerators. So 2 times x plus 2 is the same as 2x plus 4. Minus 2 times 5 is minus 10. And all of that will go over the same denominator. And I'm going to leave that denominator factored. And in most cases, you do just leave that denominator factored. Let's take a look at this numerator. You do have a 2x plus 4 minus 10, meaning you can combine like terms here. The 4 minus 10 is a minus 6. So we have 2x minus 6 on the top, and I still have all these factors. And you may not have enough room to get all these problems on one page, but do what you can. I don't want y'all to take 12 pictures if you can help it. All right, let's take the 2 in the top here, and we can factor out that 2 because both of these numbers are divisible by 2. So we'll say 2 times x minus 3. And then I'm just copying this denominator over. And then finally, I do have common factors I can divide out. Because I have nothing but products, these are multiplied together. These 3 factors are multiplied together. The common factor, 2 divided by 2, can be divided out to get a 1. So that can be divided out. So what's left is x minus 3 on the top, which you can just leave off your parentheses at this point. And on the bottom, you can leave these 2 binomials in their parentheses. And I put them in the other order, but it doesn't matter. Put these 2 binomials down here, and this is your final solution. Now, the next thing we have to do is we have to put restrictions on our variables. We did not have to do that in Part A because the denominator didn't have a variable in it. It just had a 12. But in this problem, there's x's in these denominators. So I need to go back through my problem and make sure I don't use an x that will produce a 0 in the denominator. Well, if I put in a 2 for my x, 2 minus 2, which that appears in just about every step of the problem, 2 minus 2 is going to give me a 0 in the denominator. So x cannot equal 2. So that's one restriction. I also can't use a negative 2 because negative 2 plus 2 would give me a 0 in the denominator here, which in that factor appears throughout the problem. So x cannot equal negative 2. So always go all the way through the problem and make sure, because sometimes we have factors divide out, but we still are not allowed to use that number. It's like the hole in the graph. We're not allowed to use that number as part of our domain of the function, so those are called restrictions on your variable. So these are your 2 restrictions. You just list them out by the side. Okay, on 1C, we have, sorry about that, guys. I don't know what happened just there. On 1C, we have 60 minus 3x over this trinomial. So what I'm going to do before I even write this down is I'm going to go ahead and factor that denominator, that trinomial, and I'll use the box method to do it. So let's put this in a box. The x squared would go in one corner, and the minus 20 will go in the opposite corner. Now let's multiply those together, negative 20x squared. The other 2 corners of my box need to have that product, and they need to have a sum of x, or 1x. So to do that, I would need to use a positive 5x and a negative 4x. That's because 5x times negative 4x is the same as this product, negative 20x squared. 5x minus 4x is 1x, which is that middle term of my trinomial. So put your factors on your side. The 2 in the left column have a common factor of x. The 2 in the right column have a common factor of negative 4. The bottom row has a common factor of x. The top row has a common factor of positive 5. So when we write down problem C, we're going to write 60 minus, and please don't factor the numerator here, because that won't help you. The only thing you want to factor in these problems, at least to start, is your denominator. All right, so we're going to put x plus 5x minus 4 in place of this trinomial. Now the one on the right has a 3x plus 9. I wouldn't factor that, but I would factor, well, actually, I don't need to factor. I have an x plus 3. All right, so notice the 2 denominators are completely different. They have nothing in common. This factor is x plus 5, this is x minus 4, this is x plus 3. But they both need all three factors the same. So what I'm going to do over here is multiply by both x plus 5 over x plus 5 and x minus 4 over x minus 4. So I have all three of them in this one. Now this one has these two, but it's missing the x plus 3. So I'm going to multiply by x plus 3 over x plus 3. All right, so now we need to multiply out our numerators, and this gets really interesting. I've got to multiply three binomials together in this numerator. Here I can multiply with a box, or I can do FOIL. I think I will do FOIL. But the denominators, don't multiply those out. You want to leave your common factors, your denominators the same as they are now. So we're going to leave our x plus 3, our x plus 5, and our x minus 4 as is. So to multiply these two binomials, let's see, 60 times x is 60x. Let's write that down. Then there's negative 3x times x, so that's negative 3x squared. And then 3 times 60 is 180. And then 3 times negative 3x is negative 9x. Okay, so I did the FOIL method to get this one. Or it's just the distributive property. You're distributing your x and then you're distributing your 3. Now to do this one, I'm going to have to use more than that because I have 3 trinomials. I'm going to multiply the 2 at the end first because those are easier to do. So x times x is x squared. And I'm going to write these on the side of a larger box. This is just a way to organize what you're doing and not get lost. So x times x is x squared. Negative 4x and positive 5x. Those two add up to what? Negative 4x, positive 5x add up to positive 1x. So I'm going to put an x here. This is plus 1x. And then 5 times negative 4 is equal to negative 20. And I'm going to put that here. The other binomial, 3x plus 9, I'll put it on the left side. And now I'm going to multiply all that out. So 3x times x squared is 3x to the third. 9 times x squared is 9x squared. 3x times x is 3x squared. 9 times x is 9x. That's the top row. 3x times negative 20 is negative 60x. And 9 times negative 20 is negative, what? 180? Hope I did that right. All right, so this box, what's inside here is this numerator, all three of these. So let's put all of that, I'm just going to extend this way out on the top here. So I need a 3x cubed plus 3x cubed. I have a 9x squared and a 3x squared. I can put those two together. So let's see, that would be 12x squared. And then I have a 9x and a negative 60x. Okay, let's put all those together. Negative 51x. That should work. All right, and then negative 180. Wow, that's a lot. Now take a look at this giant numerator. We're going to try to combine some like terms here. All right, so we have 3x cubed, and there's only one of those. So let's put 3x cubed first. And then I like to cross these out as I go so that I don't get lost. Now I have a squared term here, which is 12x squared. So let me circle that one. I have another minus 3x squared. So that leaves me with 9x squared. I'll put that second. All right, we got our x cubed, we got our x squared, so we're done with this one, we're done with this one. Okay, now we can do our x's. I think we have more than 2 of those. Let's see, we have a 60x here. We have a negative 9x here. We have a negative 51x there. All right, 60 minus 51 is 9x. And then minus 9x is 0x. So I don't have any x's. All right, and then 180 minus 180, these cross out too. So I don't have anything left. I just have this. So that's kind of nice, actually. All right, let's leave these factors in the denominator just like they are. So I'm just going to write these down again. All right, next, you want to try to factor your numerator now. I mean, once you get to the very end of the problem, then you want to factor your numerator and see if it has a common factor with one of those that's already in your denominator. So we have a 3 and a 9. That's a common factor of 3. We have an x cubed and an x squared. That's a common factor of x squared. So your common factor is 3x squared. So if we divide the first term by 3x squared, all that's left is x. If we divide the 9x squared by the 3x squared, we get 3, so plus 3. Now I'm going to copy again all these fractions in the denominator. And then you will notice, okay, we do have a product. These are all products because they're contained in parentheses, so these plus signs are not going to be a problem since they're contained in parentheses. This is a common factor, x plus 3 divided by x plus 3. Since there's all parentheses here, no addition or subtraction outside the parentheses, we can divide out that common factor. And that is all we can divide out. So our final answer will be 3x squared over x plus 5 times x minus 4. Okay, finally, restrictions on the variables. We have to go all the way back to the top. We had an x plus 3. We did divide it out, but we still can't use a negative 3 because that'll give us a 0 in the denominator. So you need to say x cannot equal negative 3 for one of your restrictions. We had an x plus 5, so that means x cannot equal negative 5. And we had an x minus 4. That was all the way through. We cannot have a positive 4 because 4 minus 4 would give us a 0 in the denominator. And so those are the only restrictions for this problem. Okay, we're on the last one on this part, and just take heart. These are the hardest ones for sure. Adding and subtracting rational expressions is time-consuming and tedious. Multiplying and dividing is a piece of cake in comparison. So first of all, you'll notice these denominators are both trinomials in two of our fractions. So we're going to go ahead and factor those trinomials, and I'm going to use reverse FOIL instead of the box, but please use the box if you're not able to do reverse FOIL to get this. All right, so let's leave the 2 alone, and in this denominator, I noticed the 2x squared. So I know there is a 2x and an x on the left side of my two binomials. And then I noticed the 3, so I know I'm going to have a 3 times 1. So the question is, where's the 3 and where's the 1? Well, since there's a 7 in the middle, I really need the 3 to be here, because that gives me 6x when I multiply these two. And the 1 needs to be here, but that gives me a 1x. A 6x and a 1x add up to 7x, which is the middle term. So those are my two factors using reverse FOIL. Now the other one is actually easier to do reverse FOIL. So I'm going to do a minus sign, and then I'm going to do, leave that numerator x. And this time I have x squared minus 2x minus 15. Well, that means these two terms are x's, so x times x. 15, I'm going to need a 5 and a 3 because I'm seeing 2. 5 times 3 is 15. The only other one would be 15 and 1, and that won't work. I need the 5 to be negative and the 3 to be positive because negative 5x and positive 3x is going to add up to negative 2x. So those are my two factors using reverse FOIL. And then finally, we have a plus 1. Okay, now, notice none of the denominators are alike. This doesn't even have a denominator, so let's put it over 1 so that you'll at least have a fraction. So what I need for this first one is I'm missing the x minus 5. So I'm going to multiply this top by x minus 5 and the bottom by x minus 5. The middle one is missing the 2x plus 1. It has the x minus 5. It has the x plus 3. It needs a 2x plus 1. So we're going to multiply the top by 2x plus 1 and the bottom by 2x plus 1. And then for the 1, you need all of that. You need 2x plus 1, x plus 3, and x minus 5. So I'm just going to try to squeeze them in here. 2x plus 1, x plus 3, and x minus 5. In any order, really. Alright, so both numerator and denominator need that. Alright, so I know y'all can't read that, but I'll blow it up when I get to the next step. Alright, so for the numerators, I do need to multiply these out because I'm going to be combining like terms on the top. So let's go ahead and multiply out 2x minus 5 and get 2x minus 10. Multiply negative x times 2x, and be really careful because this negative really goes with that x. So negative x times 2x is negative 2x squared. Negative x times 1 is negative x. And then here you're multiplying 1 by all of that. Oh, fun. So we got to multiply all three of those together. So I'm going to step over here to the side and multiply these last two together first. And I'll make one of those big boxes again. This is just an easier way to keep track of what you're doing. You can do it with just distributive property, but it gets tedious. So let's see, x times x would give me x squared. I'm going to put that on the bottom of this box. Negative 5 times x is negative 5x. 3 times x is positive 3x. So that would be, actually we just did this one. Isn't that, yeah, it's this trinomial. So it's x squared minus 2x minus 15. So I'm just going to copy that down here. Minus 15. The other binomial is the 2x plus 1. So we're going to put that on the side of the box. Now let's multiply and fill in this box. So 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. Not bad. 2x times negative 15 is negative 30x. Okay, I think I got the bottom row. Let's do the top row. This is the easy row. Everything's times 1, so this will just be x squared, this will be negative 2x, and this will be negative 15. So now my numerator here is going to have a 2x cubed, and then I'm going to combine my x squares. Let's just go ahead and do all that at once. Alright, so in my numerator, if I use all of these and all of the ones inside this box, my largest degree term is my 2x cubed. So I'm going to put that first, 2x cubed. So I've done that one. Alright, now I have a negative 4x squared and an x squared. If you combine these, you get negative 3x squared. But you also have this negative 2x squared. So if you put negative 3x squared and negative 2x squared, you should get negative 5x squared. Alright, so I've got both of those. Alright, next I can combine these two x's. So negative 2x and negative 30x is negative 32x. But I have a 2x. Well, that would make it negative 30x. And then negative 1x would be negative 31x. So that's that. Alright, and then I have a negative 15, but I also have a negative 10, so that's a negative 25. Alright, so my denominators here are all of the above, so let's put them back. We got 2x plus 1, x plus 3, and x minus 5. So the question is, are any of these factors going to divide out of that lovely trinomial? So I'm going to use my calculator here, and we're going to see if any of these are factors. And a quick way to discover that is to go ahead and graph 2x cubed minus 5x squared. By the way, you can use Desmos for this too, but you'd have to zoom way out. This is the one thing I really prefer on the TI over Desmos, because this table here is a whole lot easier to construct and use. Alright, so what I need to know is negative 3 going to factor out of this? So go to negative 3, and the y value there is negative 31. So that means this will not divide out of this. What about x minus 5? Well, if you go to 5, the y value there is negative 55. So next, what about the fraction here? This is a fraction. If 2x plus 1 is equal to 0, then 2x would be negative 1, and x would be negative 1/2. So the 0 here is negative 1/2, and I don't see that. So let me show you how to figure out if that's a root. Let's type variables, y variables 1, 1, and let's plug in negative 1/2, and I'm getting out a negative 11. So that's telling me none of these factors will go evenly into that polynomial. Thank goodness I don't have to divide out anything. So this is my answer, as simplified as it can possibly be, and I now just need my restrictions. So x cannot equal negative 1/2, because that would make this one 0. X cannot equal negative 3, and x cannot equal positive 5. And let's go back and make sure I didn't divide anything out. I don't believe so. So we're good. That's the whole solution with restrictions. Okay, so luckily we're out of that part. That's the hardest part of this assignment. We're into some multiplication now. So Alicia has multiplied these two rational expressions, and this is her work, and it has a thumbs down, meaning she made some mistakes. So let's see what she did. She said, well, I could see her mistake right here. So you'll notice she started dividing things out here, and we've talked about this before. With this minus sign here, these are not products. These are not factors. You cannot divide out things that are added together. You can only divide out things that are multiplied if they're products. So her error is here, and we need to write that. Cannot divide sums. I know y'all can't read that, but you cannot divide sums or differences. You have to have products only. You need to divide out factors. So what we'll do is we're going to create factors out of this first fraction. The 3 and the 6 have a common factor of 3. So factor out a 3, and now we have factors, 3 and x minus 2. So those are now multiplied. On the denominator there, we have an 8 minus 16. Well, those have a common factor of 8. So we can factor out x minus 2. 8 times x minus 2. Now you have factors. So these are things that can be divided out. And then she has 4x over 9. Well, you can't really break down 4x and 9. So let's see what we can divide out. Now we can divide out common factors. 3 and 8 are not divisible, but 3 and 9 are. So you can divide this 3. See, it's all multiplied. There's no adding inside here. It's only in those parentheses, and we've already divided those out. So 3 goes into 9 3 times. And 4 goes into 8 twice. This x will not divide out because there are no other x's in here. So your numerator will just have an x. And your denominator will have a 3 times a 2, which is a 6. Now let me show you a neat trick. The restrictions on the variables are 2, and that's true, so she did that part right. You can't use a 2 because this 2 would give you a 0 right here. So we do want to indicate our restrictions. That's not a negative, that's just 6. So what I want to do is show you something cool. Let's go to y equals and put in the original problem. So I'm going to type alpha y equals enter. And by the way, this works on Desmos as well. They don't have a table that works the same, so you have to kind of create either your own table, which takes forever, times 4x over 9. So I'm going to do 4x over 9. All right, this is the original problem. Now my solution was x divided by 6. So alpha y equals enter. I'm going to put x over 6. Now when I go to second graph, notice the table, both y1 and y2 are the same thing. The only difference will be that restriction at 2. At 2, there'll be an error message in the left column because that common factor had not been divided out. But everywhere else they'll match. So you'll know this is the correct simplified solution. All right, question 3 is multiplying and dividing. Now this looks like an enormous amount of work, and it is some work, but it's nowhere near the amount of work we just did. So I think you'll appreciate these a lot more. For 3A, I'm going to start by factoring everything. So, and that's not like adding and subtracting. We normally don't factor our numerators, but in these you just go ahead and factor everything. So in the numerator, you'll notice I have A, 2x squared minus 32. So 2x squared minus 32 has a common factor of 2. So let's factor that out. And then that has difference of squares. So that will give me two binomials, x plus 4 and x minus 4. So that's my numerator on A. Now the denominator on A, and I'm just going to do all these out and then we'll write it at the end, is x squared minus 10x plus 24. So this one I'm going to use reverse FOIL on. I usually do that when I don't see a number in front of my x squared because it's usually really easy to figure out without the box. But if you need a box, go ahead and make your box to find your factors. So we have x times x, which is x squared. I need a 24 that's positive, and I need my x's to add up to negative 10. Well, if I do 6 and 4, positive 6 and positive 4 add up to positive 10. But if I do negative 6 and negative 4, that will still give me the positive 24, but it'll add up to negative 10. So that's going to be my factors for that one. All right, the next one was x squared. This is on the top on the right, minus 4x minus 12. And so for this one, for reverse FOIL, I'm going to use x times x, which is x squared. I need to have a product of negative 12, and I need my x's to add up to negative 4x. So let's see, if I use 4 and 3, that's not going to work because negative 4, positive 3 adds up to negative 1, so that's not going to work. But let's do 6 and 2. I believe that'll work. So I could do a negative 6 and a positive 2 because negative 6 and positive 2 add up to negative 4. So that will give me the x's with the correct sign. So that works. And then finally, the last one, I'll just do that one in the problem. We're going to factor out a 10 and get 10 times x plus 2. So let's write out the problem again using our factors we just created. So for A, the numerator of the first one is going to be 2 times x plus 4 times x minus 4. And the denominator for the first one will be x minus 6 times x minus 4. Times the second fraction has a numerator of x minus 6 times x plus 2. And the denominator, I haven't done this one yet. I need to factor out this 10 and get 10 times x plus 2. All right, so that's the extent of your work because most of the rest of this is dividing out common factors. Notice we have no adding and subtracting in between these parentheses. This is all multiplied together. These are all factors. So I am able to divide out all the way across here. So notice this x plus 2 can divide out that x plus 2. This x minus 4 can divide out that x minus 4. This 2 and this 10 can be divided as well. 2 will go into the 10 5 times. And then this x minus 6 can divide out this x minus 6. So do you see, there's really very little left here. The only thing left in the numerator is the x plus 4. And since that's all that's there, you can remove your parentheses. And then the only thing left in this denominator is this 5. So this is the simplified fraction. It's the simplified rational expression. Finally, what I want to do is go back and look at my denominators and make sure I list all my restrictions. I cannot have a 6 because 6 minus 6 would give me 0. So I'm going to say x cannot equal 6. I cannot have a 4. Okay, because 4 minus 4 would be 0. I cannot have a negative 2, so x cannot equal negative 2. All right, let's make sure if I divided anything else out. I believe that's all. And so that is the end of question 1, or 3A. All right, let's go on to 3B. Okay, we're still on 3B, multiply or divide each and list restrictions. So in this case, I'm going to go ahead and factor everything before I write this down again. So the first numerator just has a 6x, so I'm going to leave that there. The denominator has an x minus 9, so I'm going to leave that there, but I am going to put parentheses, because in a minute I may have another x minus 9 and it'll be easier to see it. So in the second fraction, we have an x squared minus 10x plus 9. So I'm going to go ahead and factor it straight into the problem. So we have x times x to get x squared. To get 9, and I need it to add it to negative 10 here. So let's use a negative 9 times a negative 1. Because negative 9 plus negative 1 would give me the negative 10x in the middle. In the denominator, I have a 2x plus 12, so let's factor out the common factor 2 and get 2 times x plus 6. All right, for the third one, I have an x plus 6. I'm going to put that in parentheses. And then in the denominator, I have x to the 4th, so I'm going to do this one over to the side. So let's do a little bit of arithmetic here, a little bit of factoring over to the side. If I have x to the 4th, I can factor out an x squared, because all three of these terms have a factor of x squared. So let's put x squared times x squared plus x minus 2. And so now my common factor, x squared, needs to go over here. So let me just write that in red so I can keep track. And then this trinomial, I'm going to factor that out as well. So x squared, I need an x times x. For 2, I'll need a 2 times 1. But I need my x's to add up to positive 1. So if I have a negative 2 for my product and a positive 1 for my sum, let's put the positive on the 2, positive 2, and the negative on the 1. That's because 2 minus 1 would give me the positive 1. X that I need. All right, so now that I've done my factoring, I'm ready to start looking for common factors. So notice there's an x minus 6 here, and I immediately notice the x minus 6 up there, so I can divide those out. I see an x minus 9 here, and another x minus 9 over here in the denominator. Again, these are all multiplied now, so I can just divide out all the way across. I see an x minus 1 here, and an x minus 1 there. Now, I do see an x plus 2 here, but I don't see any other x plus 2's in the numerator. And something I didn't point out earlier is you only divide out if a factor is in both the numerator and the denominator. Don't start dividing out factors that are both in the numerator, because that's not a 1. That's something else. So we're factoring out 1's is what we're doing. The only thing left here is 6x and x squared. Well, there is no other 6, but I do see this 2. So 2 will go evenly into 6 3 times. So I could divide the 2 into the 6. And this x and this x squared, they have a common factor of x. So I could divide out an x here. And if I divide out an x here, it's going to get rid of that exponent and just be an x. So I'm just going to scratch out that exponent. So let's see, on the top, the only thing left that I'm seeing is that 3. So my answer should have a 3 on the top. And on the bottom, this x is still here, so I don't want to forget it, x. And this binomial x plus 2 is still here. And you do not have to multiply those out. You can. If you want to simplify that, that's x squared plus 2x, but you don't have to. So this is my simplified, or almost simplified, expression. We do need to list our restrictions, and there's quite a few here. I cannot have a 9, because 9 minus 9 is 0. So x cannot equal 9. I cannot have a negative 6, because negative 6 plus 6 is 0. I cannot have a 0, because 0 squared is 0 here. So x cannot equal 0. I cannot have, let's see, a negative 2. Negative 2 plus 2 is 0. Wow, there's a lot of restrictions here. And then I cannot have a 1. 1 minus 1 is 0. You could just list out the numbers x cannot equal with commas if you don't want to write them down vertical, but you do need to list them somewhere. So those are the restrictions, and that's all for that problem. Question 3C, 8a cubed b divided by 5c is divided by 10ab squared divided by 3c. So in this case, this is the first time, I guess, in this part, we have two expressions that contain no adding or subtracting, which is kind of interesting. It makes it a little bit easier. The only thing we're going to really need to do here is to take the reciprocal because of the division of the fraction on the right and then divide out common factors. So it's a pretty short process. On C, leave the fraction on the left. So we'll have ax cubed b, 8a cubed b, I don't know where I got x, and then 5c underneath, and then times, put 3c over 10ab squared. All right, so I've taken the fraction on the right, taken the reciprocal, and changed this to a multiplication problem. All right, now let's see what we can do. I notice the c over c, these will divide out, so let's go ahead and get rid of those. This b will divide out one of these b's. So b and b squared will leave you a b on the bottom. So I'm just going to cross out this exponent. It's actually like an exponent of 1 now. This a cubed and this a will divide out and leave you with an a squared on the top. So I'm just going to put a squared on the top for that a cubed. The 5, there is nothing that will divide out the 5. Be very careful. The 10 and the 5 are both in the denominator, so you can't divide anything out. The 3, there is nothing on the bottom divisible by 3. But this 8 has a factor of 2, and this 10 has a factor of 2, so I could divide both by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. And so I've divided out everything I can. So let's see what's left. We have a 4 and a 3 in our numerator. So let's multiply 4 times 3 and get 12. I have an a squared in the numerator, and the b is gone, and the c is gone. So I just have an a squared left on the top. On the bottom, I have a 5 and a 5, so that's 25. And I have b, and that's to the first power because I've divided out one of those, and that's all. So this is your simplified solution. The restrictions on the variables, a cannot equal 0, b cannot equal 0, c cannot equal 0, because these denominators need to all be positive. And c, remember, was up here too. So if that had been a different variable, we would have had to include it because it was originally in the denominator. Question D, it's a division problem. So again, we'll take the reciprocal of the rational expression on the right and multiply. On the left side, you have a 14x squared, so just leave it. In the denominator, you have a common factor of 4. So you'll get 4 times x plus 5. On the right, I'm going to go ahead and factor these as I flip the fraction. So x squared minus 25, those factors are x plus 5 and x minus 5. So let's put those on the top of the fraction. And then at the bottom, we're going to factor out 7x squared minus 21x. The 7x is a common factor. So you'll be left with x minus 3. All right, take a look at what's left, and you'll notice the x plus 5 factors are common, so those can be divided out. There is no other x minus 5 on the bottom. There is no x minus 3 on the top. The 7 goes evenly into 14 2 times, so you can divide the 7 into the 14. The x will go into x squared x times, so that'll just leave you an x. And then finally, we have a 2 and a 4. Those are divisible by 2, so you can divide the 2 into the 4 and get a 2. So let's see what's left. On the top, there's just this x and this x minus 5. So x squared minus 5x, or you can leave them if you want, because I know that doesn't factor anything out on the bottom. And then we have the 2. We have the x minus 3. You don't have to multiply it out. You can leave it. And so this is my answer. And then my restrictions are x cannot equal 3 because of that. X cannot equal 0 because of that. X cannot equal negative 5 because of this one. And x cannot equal positive 5 because this originally was in the denominator, this x squared minus 25. So I cannot have a positive 5 either. So those are my 4 restrictions on the variable. Okay, we're finally done. This is going to be our last problem. So all of these need to be factored. So in the first expression, you have a common factor of y squared. So that will leave you with x minus 6 in parentheses. Underneath, you have a 2x plus 18, common factor 2, so x plus 9 in parentheses. For the second fraction, you're going to do the reciprocal. So take your 8x plus 24 and factor out your 8, and you'll get x plus 3. For your numerator, it's now your denominator. You have a common factor y, and so you'll get 2x plus 1. For your last fraction, it's again a division, so you will do the same, do a multiplication, and then you will factor the numerator and put it in the denominator, and the numerator. So I'm going to do the top one first. I am going to use reverse FOIL, but please use the box if you need it, particularly on this one because it has a 2 in the front. So notice I have a 2x squared, so I'm going to use a 2x times x to get my 2x squared. I have a 2, so I need a 2 and a 1. So the question is, where does the 2 go? Where does the 1 go? Well, you need the 2 here so that you'll get a 4x when you multiply these two. And you need the 1 here so that you'll get a 1x when you multiply these two. Since I have a negative 3x, I need my negative to go on my 2. That'll give me the negative 4x. And my positive to go on my 1. So that'll give me a positive 1x. So negative 4x, positive 1x equals negative 3x. So these are my 2 factors for this denominator, which is now my numerator. So for the other one, it's easier to do reverse FOIL because there's no number in front of x squared. So hopefully y'all can do this by now. Let's put x times x for x squared. For 18, we can use 6 times 3. I need a negative 6 and a positive 3 because negative 6 and positive 3 add up to negative 3. All right, finally, I'm ready to look for common factors. So notice 2x plus 1s, and these are just random. You'll notice I don't have any order I go in. I just start looking. I see an x plus 3 here and here. These can divide out. I see an x minus 6 here. It can divide out. Let's see. I have a 2 and an 8. 2 goes into 8 4 times, so I could divide out a 2. I see an x minus 2 up here. I don't see one over down here anywhere, so I'm not going to be able to divide that out. I see an x plus 9, but I don't see one on the top. So the only thing left are these y's. So y will go into y squared y times. And so that's it. The numerator will have a 4, a y, and I'm not going to multiply this out, and an x minus 2. Just leave it. And the denominator will have, the only thing left here is the x plus 9. The restrictions on the variables, and there's a bunch, and I'm going to list them out horizontal to show you how that looks if you don't want to list them all. So I'm going to say x cannot equal negative 9, comma, x cannot equal positive 6, that's here. It cannot equal negative 3. It can't equal either of these, so it can't be positive 2 either, because this one was flipped. It can't be negative 3, we already said that. It can't be negative 1/2, because negative 1/2 here would make this one 0. And I think that, it can't be 0 right here. Y cannot be 0. So y cannot equal, that's a different letter, so we got to write that one separate. Y cannot be 0. And so that's it. We got 1, 2, 3, 4, 5, 6 restrictions on the variables for this problem. All right, that's it, guys. So what I want you to do is I'll let you 2 practice problems to do at the end. I want you to do those 2 practice problems, and then you will submit this assignment. We'll have 1 addition and then I'll do 1 division problem. And then finally, you'll do your exit ticket and submit. As always, if you have any questions, leave me a comment. I'll get back to you. Stay safe.